It's Tuesday. Today we're going to talk about 9-5. I actually split it into 2 days. I could have probably put it all in one day, but I've had some longer lessons, so I figured we'd go ahead and just have two sort of easier days in a row. So just day one. On day one, we're just going to solve nonlinear systems graphically, and also we're going to do some nonlinear inequality systems. I'll just show you how to do two of those at the end. All right, so a nonlinear system is just literally, it has to have two or more equations, and it has to have one of those be not a linear equation. So it can have one linear equation, but it has to have at least one nonlinear equation to be a nonlinear system. All right, so to solve these, you're just going to graph both of them separately. I'm just going to color code. So my first one is actually a linear. So when I graph it, it should be a line. So I'm just going to graph this as I know how. Well, it's in slope-intercept form. So intercept is 1, slope is 2. So I'm going to go up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and make as many dots as you can. That way the intersection points will hopefully actually be one of these dots. Okay, my second equation is, hopefully you can see that that is quadratic. And you can do this a couple different ways. I just need to be able to graph this. You can make a table of values if you need to. You could put it in slope-intercept, not slope-intercept form. You can put it in vertex form. So I'm just going to go ahead. This guy actually already is in vertex form, because technically vertex form is that ax minus h squared plus k stuff. And there's really nothing in here, so my vertex is actually 0, 1. So I do about vertex at 0, 1. So there's that guy. And then we know that out front is the multiplier for the 1, 3, 5 pattern. And there's no number out front, so it is a 1, 3, 5 pattern, and it's going upwards because it's positive. So from this dot, go up 1 to the right 1, up 1 to the left 1. And then go up 1, 2, 3 to the right 1, and up 1, 2, 3 to the left. Okay, and hopefully you've done your dots pretty well, so I can actually see it crosses 2 times. So I'm going to go ahead and finish graphing this guy. He is a quadratic. And hopefully you can see a quadratic can only cross at most 2 times. So he did cross here and he did cross here. So my answers are 0, 1. You have to have ordered pairs, so parentheses, and 1, 2, 1, 2, 3, 4, 5. So 2, 5. So it is both those answers. So when you do these on Delta Math, make sure you put those parentheses in so that it'll count it correctly. Also, just a quick side note, if you have a quadratic, like I said, it could cross at most 2 times. It could cross no times, or it could cross exactly 1 time, or it could cross at most 2 times. So these have the option of having no real solution, 1 solution, or 2 separate solutions. All right, our next example has another linear, so that's linear. I'm going to go ahead and put a dot at -1, and my slope is +1, so up 1 to the right 1, up 1 to the right 1. Just going to go ahead and put in a whole bunch of these dots. So hopefully if it crosses exactly at a point, I will have some nice, neat dot to find those order pairs. Okay, my next thing is an exponential. Now exponential, we've learned a bunch of stuff about it, but they're really just kind of hard to graph as is. I do always know an exponential has an asymptote at that value there, that minus k or plus k. So I do know there's going to be an asymptote at -2. And so I know that it's positive, so it's going to open upward, and it's got a multiplier of 3, so it's going to do something like this up here, but it's really hard to know how that graphs beyond that point, so I am going to go ahead and make an XY table. We always do a -2, a -1, a 0, a 1, a 2, and if you need to do other points, just do that otherwise. So to save time, I'm just going to go ahead and use my calculator. You could always just plug these guys in, or use the calculator emulator that I've had you download. It's exactly the same as this TI-84. So you just open that program up and you just type in. You go to y equals, type in the function, and then press second table to find your values. And I'm just going to go fill in my values. My values, which you can't see on the screen, are -1.889, -1.6, well, I'm just going to round, 6.7, a -1, a 1, and a 7. So I have those values, just go plug them in. So I'm just going to start with the easy ones. So 1, 1's pretty easy. 0, -1's pretty easy. 2, 7 won't actually fit on there. -1, 6.7 is probably here-ish and here-ish. And again, it is going to get forever close to that asymptote. And I do know it's going to go up drastically. but I don't really care what happens beyond that point because it crosses only one time. The exponential could cross twice if it went down and then back up, but it just bumps it real quick and then it's done. So then this ordered pair answer is 0, -1. And that is the only answer. You can obviously check these guys. So if I went back to my calculator and 3 to the 0 minus 1, if that gives me a -1, I'm good to go, and plug it in the other one. 0 minus 1 is also a -1, so they both have 0, -1 as a solution, so it does work for both. But graphically, I mean, if you've graphed them both correctly, then it should be here. Also, if you have a graphing calculator, just graph them both under y equals, and you can just see how the graph looks and double check it that way. All right, next one, we have a quadratic and exponential. So my quadratic, if it was in vertex form, it'd be fantastic, but it's not. It is in standard form. So I'm going to find my vertex by doing -b over 2a. So remember, -b over 2a. So -2 over 2 times -1. -2 over -2 is 1. But don't forget that value is only half of my vertex. So I get a 1. I'm going to plug it back in. So I'm going to get a -1 plus 2 minus 2. So I'm just going to get a -1. So this guy now has a vertex of 1, -1. So I'm going to go graph that. And I love my 1, 3, 5 pattern. Multiplier is always that number on the outside of that a value. So it's a -1, 3, 5 pattern. So I'm going to go down 1 over 1 to the left and right, and down 3 over 1 to the left and the right. So now I have my quadratic. Okay, then my next one is exponential. Again, pretty hard to just graph these outright, but there is no plus or minus, so it does have an asymptote at y equals 0. And I am going to go ahead and just make an xy table, and I'm just going to copy that down to save time. All right, again, I just chose my values, -2, -1, 0, 1, 2, and I just plugged it in the calculator and copied those values. So I'm going to go ahead and graph that. So I'm going to graph the easy one first. So 0, 2, 110 is way up there. -1.4 is here-ish, and then 0.08 is here-ish. And again, it's going to forever get closer. And 10 is way up there, so this guy actually goes up pretty high really fast. So looking at my intersection, there is none. So this is actually going to be a no solution answer there. Okay, and you could easily just graph this on the calculator if you have that, or if you did get some solution for some reason, if you graph this wrong, if you plugged it into both equations, it would not work because there's nothing that's going to work for both of these. So if you did get an answer, you can just double check your work. All right, so our last example of these, we have a quadratic and a linear. So the quadratic, I'm going to go ahead and do it's in standard form, so I'm going to do -b over 2a to find my vertex. So -1 over 2 times 1, that's going to give me -1/2. I'm going to plug that back in. I'll go ahead and just tell you it's -1.25. Okay, so -b over 2a, let's find your x value, and just plug that -1/2 straight in, and it's going to give you your y value. All right, so normally you would graph this -1/2, -1.25, and you would do the 1, 3, 5 pattern, but then your numbers are all going to be decimals, and which is normally fine, but this is an honors question, so I made one that doesn't work out very nicely. So on this one, I actually would go ahead and make a table. I mean, I could do the 1, 3, 5 pattern, but I'm going to go ahead and tell you now that's not going to work out as one of your solutions. So I'm going to go ahead and pause and make my table. All right, so I went ahead and made my table, and of course, you've got to put your vertex in the middle. So I went ahead and put my vertex in the middle, and my graph is really tall, so just looking by how much information I gave you, you're probably going to need some higher numbers. If you start doing these numbers over here, you're going to get, and it's obviously the same thing on both sides, you're going to get -1 and 1, a 1 here and a 1 here. That's going to give me this high on the graph. So I'm going to have to keep going, so 5 and 5. That's going to give me this high. So I just went ahead and chose numbers that would give me values all the way up to the top of the graph in case I needed those. So I'm going to go ahead and graph those. 5 and 11. 5 and 11. Okay, do my best to make a smooth parabolic curve. But really, in the end, you just want to make sure your dots are pretty good because that's where those intersections will likely be. All right, and then the last one is linear, so crossing at a +3, and then he's got a -2 slope, so just count up 2 over 1, up 2 over 1. And this is why the 1, 3, 5 pattern didn't work, was because it does cross off the 1, 3, 5 pattern. Okay, so I have my linear, So, boom, 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 boom. All right, two intersections. Just those two ordered pairs are -4, 11 in parentheses and 1, 1 in, well, it's terrible parentheses, in parentheses. And if I took both these values and plugged in -4 and 11, -4 and 11, it would work, and then 1, 1, 1, 1, it would work. All right, so hopefully I have enough time to do these last two. All right, these last two are very similar in the fact that you're still going to graph them, but these are inequalities, which means we're going to shade, which we've done these things before, just never with quadratics and things. Okay, so I would just color code if you're actually doing it. So x greater than -1, don't forget when you're doing x's, it's an up and down line, and it's not included because it's got the no equal to, so it's going to be dashed. Okay, x greater than -1 is going to shade to the right. Okay, choosing a different color, I'm going to go over here, and x is less than or equal to 1. So that is going to be a solid line at x equals 1, and less than or equal to shades left. So there's shading left. Okay, not the brightest color on the page here. Okay, that's okay. And I'll go ahead and do the last one in pen so it's very clear. All right, this last one is a quadratic, and he is in vertex form, so his vertex is the opposite of the inside, so still 0, same as the outside, so 0, 6. So 0, 6, put a dot, and he does have that negative multiplier, so he's going to go down 1, 1, 2, 3, and 1, 2, 3, 4, 5. 1, 3, 5 pattern. Same exact thing as before, just double check, is he solid or dash? Well, he's going to be solid, so I'm just going to connect these guys with a solid line. And shading up or down, I want to highlight the y values. So I want lesser y values. Y is less than. So I have two options on a quadratic. I can either shade on the inside or shade on the outside. Well, shading on the outside would highlight +8, and it would not highlight -8. Well, I want the least y value available, which is -8. So I do want to shade on the inside of that quadratic. And just because my answer is not super clear, I am going to shade just the part that works. So it's to the right of the dashed, to the left of that solid, and it's going to be everything on the inside there. My final answer is just that little curved sliver that goes down forever. That's the only section that's greater than this dashed -1, less than the solid 1, and then below that quadratic curve. I'm choosing the lesser y values. Okay, if you were finding a solution, you just pick anything in here. 0, 0 works. And you could plug in 0, 0, 0, 0 for every one of these inequalities, and it would be true statement. All right, last one. I actually went ahead and changed this just to a greater than, not equal to, so we can have a little bit of variety. But I have hopefully you see this is a quadratic, he has a square in there. So my vertex is opposite of the inside, same as the outside, so 4, -5. So 4, -5. And he has a 1, 3, 5 pattern. So up 1, 2, 3, up 1, 2, 3, 4, 5, doot, doot, and doot. Okay, this guy is solid, so I am going to go ahead and connect him with a solid line. Okay, and then again, less than. I want to highlight the lesser y value. It's a little confusing because it's off to the side, but this is going to go up forever, and it's going to cross over somewhere up here. So say like y to the 20th is up here. Well, I want the lesser y values, so the lesser y values are actually going to be on the outside because that would give me -8 as a y value as opposed to +20. So I do want to shade on the outside of this quadratic, everywhere on the outside. Okay, and then the next one is an absolute value function, and vertex again is the opposite of the inside, same as the outside, so -3, 5. And hopefully you know the absolute value is a straight line, and the slope is the number on the outside. So he's actually going to go, oh, here comes the gun. He's going to be dashed, go in this direction, and dashed, going this direction. I'm not going to change enough time, I got like 50 seconds. Okay, so sorry, dashed across the board. And then he's y greater than, so same question. Do I want to highlight y +8 or y -8? Well, I want the greater y value, so I want everywhere on the outside up here. So I'm going to highlight this and this and this and this, but also don't forget over here. So that is weird, but that's just how absolute value and quadratic graph together. So nonlinear systems could give you some weird, wonky answers, but my answer could be like 10.5 or -7.6 or something like that. So I do have a large range of answers.